What if we could watch our dreams like movies? Thanks to recent breakthroughs in neuroscience and artificial intelligence, this one science fiction idea is inching closer to reality. Welcome to NDE Insights. Today, we explore a revolutionary question. Can we record and visualize what we see in our dreams? Every night during REM sleep, your brain enters a state of high activity. It produces vivid sights, sounds, and emotions, all without any input from the outside world. Key players in this process include the visual cortex, generating internal images, the limbic system, fueling emotional content, and a quiet prefrontal cortex, making dreams feel bizarre or illogical. These brain activities leave unique patterns, and scientists are learning how to read them. So how do we decode a dream? Starts with fMRI, or functional magnetic resonance imaging. This technology tracks blood flow in the brain. When a person views an image while awake, the fMRI creates a neural fingerprint of that visual. Here's where it gets fascinating. During REM sleep, scientists can compare those fingerprints to the brain's activity and decode elements of a dream, like a car or a dog. In a 2013 Japanese study, researchers reached nearly 60% accuracy identifying dream objects using this method. Enter AI. Machine learning models trained on brain scan data are now reconstructing blurry but recognizable dream visuals. These systems take raw neural signals and produce low-resolution images like abstract glimpses into the mind's eye. It's far from Hollywood-level clarity, but it's a massive leap in understanding human consciousness. But this technology isn't limited to visual dreams. Other labs are working on mapping auditory content like voices or music in dreams by observing how the auditory cortex activates during sleep. This could eventually help decode not just what we see, but also what we hear in our dreams. And there's more. Researchers are experimenting with targeted dream incubation, a process where external audio cues, like a word or sound, are played during sleep to influence the content of dreams. Imagine choosing your dream theme before falling asleep in Island, City of Memory, and having your brain pick up on that signal during REM. MIT's Dream Lab has already shown that it's possible to guide dreams towards specific topics in controlled experiments. This opens the door to using dreams intentionally for creativity, problem solving, or even trauma therapy. But all of this comes with serious questions. Dream recording raises major ethical concerns. Should anyone, scientists, governments, tech companies, have access to your dreams? What happens if subconscious content is misinterpreted or leaked? And what rights do we have over the data produced by our brains? Some ethicists argue that dream privacy should be treated as a fundamental right, just like freedom of thought or protection from unreasonable search. There's also the risk of false interpretations. Brain data is incredibly complex and context-dependent. Two people dreaming of the same object might show very different neural patterns. The single pattern could be linked to multiple memories, meanings, or emotional states. That means dream decoding must be handled with caution, transparency, and rigorous peer review. But let's also think about the positive potential. Imagine helping someone with PTSD process traumatic dreams by visualizing and confronting them safely. Or imagine a paralyzed person communicating through dreams, where direct speech isn't possible. What if artists and writers could mine their subconscious for raw, uninhibited creativity? There are also implications for lucid dreaming, the rare but trainable ability to become aware that you're redreaming while still asleep. Some studies suggest that brain-computer interfaces could assist in entering or maintaining lucid states, offering a new realm of conscious experience. Then there's the question of long-term storage. If we can record a dream, can we save it? Could your childhood dreams be archived? Could couples share dreams with each other? Could entire libraries of human dreaming become part of our collective digital memory? These ideas might sound fantastical, but so did flying machines, the internet, and a generated art. Right now, the main technical limitations are low resolution of decoded imagery, slow scanning speeds, and high equipment costs. fMRI machines are expensive and not portable, but with rapid progress in wearable EEGs, machine learning, and neurofeedback systems, we're likely to see home-accessible versions in the coming decades. Major tech companies and neurotech startups are already investing in brain interface technologies. Elon Musk's Neuralink, Meta's neural wristbands. Startups like Kernel are all working toward tighter integration between brain signals and digital devices. We may be entering a future where the brain becomes the next user interface, capable of outputting not just thoughts, but dreams, images, and even intentions. The implications are vast for education, mental health, personal growth, and yes, even entertainment. But we must move forward with caution. Technology should serve consciousness, not the other way around. We are entering an era where the inner workings of the mind are no longer hidden. Dreams once private, fleeting experiences may soon be observable, recordable, and even interpretable. If you're fascinated by the frontier of consciousness, stay tuned to NDE Insights. Like, subscribe, and let us know in the comments. Would you want your dreams recorded? What would you do with them? Thanks for watching.